Hello, you absolute legends. My name is Don Cavanaugh, and let's talk about the entropy term here. The entropy term is a way to describe matter based on its position, its vibration, and its movement through space related to its state of matter. Gases are going to have the highest entropy because they have the most changes in movement, position, vibration. Solids are going to have the lowest entropy states right here. Entropy is going to have a positive or negative sign. That's what we're going to do right here. And it has the units of joules divided by temperature. Note that entropy is related to temperature directly. That's why it's in the division down here. You need to be able to predict and calculate S term. Calculate. After you've been able to predict the S term, you'll have to calculate the S term. The S term is calculated using the same tables that you use to calculate G. The tables contain H, G, and S, and we'll use the tables right here. Note the S column and note the states of matter in the formulas. Really look over this stuff with a fine-tooth comb because I make mistakes all the time not being diligent about the details here. When you calculate the S term, it is the products minus the reactants. So when you have a balanced chemical reaction, and I'm just going to write in a balanced chemical reaction right here, H2 plus O2 produces H2O. Let's make these guys a gas and these guys a liquid, okay? So when I look up the delta S for this term, I'm going to first look up the product, liquid water, and I'm going to really make sure I got liquid water, not ice, not steam, and I'm going to take that value and multiply it by dose because there are two waters there. So I'm going to multiply that value for liquid water by 2. I don't know what that number is off the top of my head, but that would be looked up off the table. And then minus whatever the heck these numbers are. These are probably 0, but I don't know what they are. But these are going to be just multiplied by 1. I can do that math in my head here. Okay? So this is going to be, the reactants are going to be 0 plus 0 joules per Kelvin, because those are the units for entropy here. When working with delta S, you need to be able to predict and calculate. We have UNO method for calculating delta S, and that is using the table products minus reactants. I hope this helps. Thank you.